in supervised learning, the goal is to create a model that can predict an output based on one or more inputs. The output of the model, in other words, the thing that we're trying to predict, is typically called the label, the target value, or the response variable. The inputs to the model are typically called features or predictors. The supervised learning algorithm will learn the optimal model by studying a training set that consists of several observations, also known as instances or samples. Each of these observations will contain values for both the features and the label. You can imagine that what a supervised learning algorithm does is accept the training data as an input, it studies that input, and then produces as its output a model. That model can then be used to generate predictions for new observations. Supervised learning tasks can further be grouped into regression and classification problems based on whether the label is continuous or categorical. A regression task is one where the target values are continuous, real numbers. Let's take a look at some regression tasks. Let's say you work for a credit card company or a bank, and you want to create a model that predicts somebody's credit score based on other information that might be available to you. It can be expensive to pull credit scores, and so maybe your company would like to have a way of being able to reliably predict a potential client's credit score without having to actually pull it. So in this case, the label or the output would be the credit score, and the input could be something like, or the inputs could be something like the customer's savings, their amount of debt, their age, and other sort of demographic information such as are they married, are they a student, things of that nature. If you work for a real estate company, you might want to create a model that predicts the sales price of a home based on characteristics of that home. So in this case, the features could be something like the number of rooms, the square footage of the house, the area of the property, the number of bathrooms, number of bedrooms, things of that nature. And then the output or the label would be the actual predicted price of the home. You might want to create a model that predicts blood pressure or cholesterol levels based on other factors such as diet, exercise, sex, male or female, or age, things of that nature. And in this particular case, blood pressure and cholesterol levels are fairly easy to measure. So the goal here would not necessarily be to predict somebody's blood pressure or cholesterol level, but to create a model that explained how these other factors affected these quantities. Perhaps you're an economist and you want to create a model that predicts what unemployment rates will be based on other economic information. So separate from regression tasks, we have classification problems. A classification problem is one where the target values are discrete classes or categories. Let's take a look at some examples of classification tasks. So going back to this bank example where we're trying to, maybe we're giving loans to individuals, and here we want to predict their credit score. Maybe we want to be a little less granular than that and just simply predict whether or not a particular loan would be high risk or low risk based on characteristics of the borrower. So here the inputs or the features would be characteristics of the borrower, and the output would be a label high risk or a label low risk. Perhaps you're a biologist and you'd like to create a model that identifies the species of an organism based on certain measurements, like the length, the width, the weight, the size of a tail, things of that nature. Classification algorithms can also perform image classification. Let's say you have a task where you have a bunch of pictures of various animals, like cats, dogs, giraffes, zebras, lions, etc. And you want to create an algorithm that reads in the pixel information from these images and then outputs a prediction of what is contained within that image. Related to that, you can create algorithms to perform handwritten character recognition. So this would be useful if you want to, say you're working for the post office and you want to create an algorithm that automatically scans addresses and translates them into actual text that can be stored within a computer. And finally, another example of a classification problem would be voice recognition. In this case, the input would be audio data, and then the output would be a label indicating whose voice it is, or perhaps just whether it's a voice of a male or a female, or perhaps the output is simply classifying the individual words as the words that are being spoken.